The concept of what existed before the Big Bang is one of the most profound and elusive questions in cosmology. Despite our advancements in science and technology, the truth is that we simply do not know. Various theories attempt to address this question, yet none have provided any definitive answers. It's a realm of unknown unknowns, where our current understandings of physics breaks down and leaves us grasping at philosophical straws. Some theories propose that the conservation of energy and the increase of entropy can offer insights into the pre Big Bang state. However, these principles alone are insufficient to paint a clear picture. Energy conservation suggests that energy cannot be created or destroyed, only transformed. Entropy, the measure of disorder in a system, implies that the universe is constantly moving towards a state of higher disorder. But how do these principles apply to a time before time itself began? Another perplexing question is, what is the universe expanding into? At first glance, it seems logical to think of the universe expanding into some pre existing space. However, the reality is far more complex. The universe is not expanding into anything, rather, space itself is expanding. This concept defies our everyday understanding of space and distance. To illustrate this, consider the analogy of an inflating balloon. The surface of the balloon represents the universe. As the balloon inflates, the surface area increases, but it does not expand into the air around it. The surface itself is all there is. Similarly, as the universe expands, it is the fabric of space-time that stretches, not an expansion into pre-existing void. This leads to apparent paradoxes. If space is expanding but not into anything, then the universe has no edge. An edge would imply a boundary, a point beyond which there is nothing. But such a concept does not apply to the universe. If the universe has no edge, doesn't it mean it is infinite? An infinite universe would imply infinite matter and infinite energy, which contradicts our cosmological theories that depend on a finite amount of energy for their equations to work. Some theories suggest that our universe might be just one of many in a larger multiverse. Imagine galaxies and stars forming, collapsing, and giving birth to new ones within a single universe. What if this process happens on a grander scale, with entire universes forming, collapsing, and being reborn within a higher dimensional space, a superverse? This idea challenges our current understanding because we lack the means to measure or observe beyond our universe. Time, as we know it, might be a local phenomenon with different rules applying in the broader universe, broader multiverse. There could be extra dimensions beyond our perception, and our universe might be a three-dimensional object embedded in a four-dimensional space. Since we are talking about the dimensions and perception of time, let me give you an idea about the nature of time. Time is a property of our universe, one of its fundamental dimensions. Evaluating the concept of time before the Big Bang is problematic because time, as we understand it, did not exist. Even within our universe, time is not uniform. Some places experience time at different rates, as illustrated by the theory of relativity. For example, near massive objects like black holes, time slows down compared to the regions farther away. Photons, the particles of light, experiences no passage of time. From a photon's perspective, the moment of emission and detection is instantaneous, even if billions of years pass in our frame of reference. This shows how time can vary dramatically depending on the context. The Big Bang was not an explosion in space, but an expansion of space itself. Before this expansion, the universe was incredibly hot and dense. Some theories suggest it might have been infinite in extent even then. The observable universe is just a small fraction of the entire cosmos, with much more lying beyond our current observational capabilities. As the universe expands, it creates space rather than expanding into it. This concept is difficult to grasp, but it aligns with our observations and theoretical models. The idea of an infinite universe that is also expanding is challenging, but it fits within the framework of our current understanding. Our understanding of the universe is still in its infancy. The questions of what existed before the Big Bang, what the universe is expanding into, and the nature of time itself are profound and complex. They push the boundaries of our knowledge and challenge our perceptions of reality. Thank you so much for joining me today, and I'll see you guys in the next one. Until then, peace.